This is a tutorial on the National Instruments myDAQ and the protoboard. To begin with, the myDAQ must be plugged into the computer using the USB cable. When it's plugged in, you'll notice that the light is blue. On the other side of the myDAQ is the digital multimeter. Notice that there are two high inputs. The left one measures voltage and resistance. The right one measures current. The myDAQ is connected to the protoboard through the input-output terminal here. The input-output terminal is connected directly to these signal blocks. The signal blocks allow you to input and output signals to and from the myDAQ directly. It has several important components, including power here and here, which can give you plus 15 volts, minus 15 volts, plus 5 volts. In order to use the power, you also need to turn it on. So for instance, here is the plus 15 volt switch, here's the minus 15 volt switch, and here's the plus 5 volt switch. If they're off, these pins will not put out any power. Next to the power is the analog output. This is how you will get signals from the function generator. It has two channels, channel 0 and channel 1. In order to get a signal from channel 0, you would connect between channel 0 and ground. To get a signal from channel 1, you would connect between channel 1 and ground. Next to that is the analog input channels, AI0 and AI1. These are two channels that you can use to read into the oscilloscope. They use differential inputs, meaning that you need to connect not between 0 plus and ground, but between 0 plus and 0 minus. It looks at the voltages at 0 plus and 0 minus and takes the difference between them. Finally, you have the potentiometer, which has a counterclockwise terminal, a clockwise terminal, and a wiper. The potentiometer is here. Simply turn it to adjust the resistance. Notice that the signal blocks have two pins each. These are connected internally, and you can choose either of them to connect to. So for instance, if you wanted 15 volts, you could connect here or here. This is the prototyping board or breadboard. It has two main parts, the terminal strips in the middle, which hold most of your components, and the bus strips on the edges, which provide power. The bus strips are connected internally across the entire row, so this pin is connected to every other pin in this row, all the way to the end. They're not connected vertically, however, so this pin and this pin are not connected. The terminal strips, on the other hand, are connected in vertical rows of 5 pins. So these 5 pins, for instance, are all connected together. This gap, however, breaks the connection. So these 5 are not connected to these 5 below the gap. You may have more than one component that needs power or ground. Rather than cluttering up the signal blocks, which have very few pinouts, it's much easier to connect to the bus strips, which have many pins. In order to power the bus strips, we simply connect between the power outs and the bus. So for instance, to achieve 5 volts power, we would connect between the 5 volt power out and the positive, and between ground and the negative. We would also make sure that the 5 volt switch is turned on. Some components have sturdy leads, like the resistor, and can be plugged directly into the prototyping board. However, other components, like the light bulb, have very flimsy leads, and if you try and plug them directly in, the leads might buckle. Instead, use needle nose pliers to gently grip the leads and guide them into the pins.